Hi, everyone. I'm Doug Black, editor-in-chief at insideHPC. And today, as part of our series of interviews on behalf of Dell Technologies, we're speaking with Carol Song. She is senior research scientist leading Purdue University's Scientific Solutions Group at the Rosen Center for Advanced Computing. Carol, welcome.
Thank you, Doug.
So let's start off. If you could just tell us a little bit about your background and some of the highlights during your leadership tenure at Purdue.
Definitely. I graduated from University of Illinois, Champaign-Urbana, with my PhD in computer science. And after that, I actually did a whole bunch of things, working in the industry on medical imaging and also the networking communications companies as well, both startups and big corporations. And in 2005, I joined Purdue. And the reason I joined Purdue was at that time, Purdue was really taking off in high performance computing. Now, Purdue has a long history doing high performance computing even before then, but 2005, that was around the time when the NSF Terra program um, started, and I was at a right place at the right time. And so I joined Purdue, and I've been leading the Purdue HPC program since then through TerraGrid. I'm also the Purdue PI for the current NSF Exceed program, leading our staff in serving the national science community. And my work also covers building data frameworks and science gateways, which are pieces that connect these advanced cyber infrastructure resources to the end users being researchers. And Anvil is really the high point of Purdue research computing and my own career.
Okay, thank you for that. Now, so we're interested today in hearing about the new Anvil supercomputing cluster under development at Purdue in partnership with Dell. Please tell us about the scale of the system, how many servers it will include, and the expected compute throughput it will deliver.
Absolutely. So Anvil is funded by the National Science Foundation in its Advanced Computing Systems and Services program. It's funded as a Category 1 capacity system. So there are a couple of things we focused on. One is capacity, both in terms of the quantity of computing hours we can provide, and also the state of art advanced HPC technologies that's in the system. And the second thing is usability. So NSF wants these systems to be highly accessible and usable to a broad range of researchers around the nation. In terms of scale, Anvil has 1,000 compute nodes. Each of them features AMD, the third generation EPIC processors, and it has a peak performance of 5.3 petaflops. Accompanying the compute nodes, we have a 10 petabyte storage system, and also with 3 petabytes of all flash memory to accelerate the data movement within the system. Envo is a comprehensive system. By that, I mean it also has other components, for example, 32 large memory nodes to support applications that needs to load in a lot of data all at once. It also features 16 GPU nodes. These are the newest GPU nodes from NVIDIA and providing an additional 1.5 petaflops of single precision computing power.
Okay, and how does Anvil fit in with Purdue's overall HPC infrastructure?
I love that question. Um, First of all, it is the largest system we've ever built at Purdue. Ever since 2005, we've been building pretty much one big cluster every year. So we've built 15 or 16 clusters. I lost count. So Anvil has 1,000 nodes, so obviously it's the largest, and also it features the state-of-the-art HPC hardware. And where it fits, um, it's also the not only it's the largest capacity system we've ever built, it's also the most diverse. Um, it includes various components that all integrated in one place. As I mentioned, the large memory nodes, the GPU nodes, along with this large pool of compute nodes. And also we have a composable system as part of Anvil, which is basically an on-prem cloud system that's orchestrated by Kubernetes. And this gives us the capacity to not only supporting the traditional HPC computational jobs, but also the newer, more heterogeneous workflows that the researchers encounter every day these days. This could include both simulations and data analytics, and also ways for them to share their software, their data, and their workflows with other researchers.
Okay.
And in terms of, with at Purdue, um, to elaborate a little bit on where it fits with Purdue. So for these NSF funded systems, there's 10% discretionary cycles that are available to Purdue. And with that, we plan to really leverage that capacity for establishing and supporting important initiatives, such as industry partnerships and collaborations in large, important programs that without such a large system, it would be impossible to support.
Okay. Thanks. And sorry for my interruption. Now we understand Anvil will have a role with the National Science Foundation's Exceed program. Uh, Please tell us about the impact the system is expected to have for research, discovery, and Exceed.
Anvil is integrated with Exceed. That means it's allocated through the Exceed allocation process. It's a peer-reviewed process. Researchers around the nation can submit their proposals for hours they need to use on the Exceed systems. Um, so Anvil is allocated through that process. Anvil, most importantly, it provides 1 billion CPU core hours to the Exceed users every year. And it also provides access to GPUs and large memory nodes and our cloud subsystem. And it's also integrated with Exceed through the frontline user support and training. Exceed has a wealth of training materials that are already available, and we're going to contribute to that training program, and also our users could benefit from the current materials. And as part of Exceed, I think it'll also help us broaden our partnerships with a broader community. As an example, Anvil is now part of the current COVID-19 consortium, which provides computing powers to researchers who are studying um, problems associated with the COVID-19 pandemic.
Okay. Now, what other challenges, or what challenges in general, are you hoping to address with Anvil? Tell us about the workloads you expect Anvil to take on.
Yes, when we proposed Anvil, one of the major issues for the national research community is that there's not enough cycles. So there was a lack of capacity, and the Exceed systems at the time are always oversubscribed, over requested. So bringing in such a large capacity system will definitely help solve that problem. And so Anvil is targeting moderate-sized computational jobs, and which is also the bulk of exceed workloads. And now some of the challenges we're focusing on improving, for example, accessibility is one of our focus, that we provide interactive computing environments that would help user to ramp up into high performance computing. Because a lot of the communities we're engaging now, they don't use HPC traditionally. For example, liberal arts, researchers in psychology, in geography, and their applications are very um, not fitting the traditional HPC kind of mode of operations. So we're providing the environments and software tools to help them get on HPC faster and make HPC easier to use. The other challenge is science is becoming more and more big data driven, um, and the workflows, the workloads becoming very often are workflows. So it's a sequence of steps researchers have to go through that may include computing intensive simulations and data driven analytics. And also, as part of their research process, they want to share their software and tools and data with other researchers and possibly also with the general public. So, having a comprehensive sort of ecosystem that includes different capabilities in Anvil under one system, we hope to address these increasingly complex workflows.
All right. Well, Carol, thanks for that update from Purdue University. And so we've been with Carol Song, senior research scientist at Purdue in the Rosen Center for Advanced Computing. On behalf of insideHPC and Dell Technology, it's been a pleasure to be with you today.
Thank you very much for having me.
Thanks.